1.3 is actually the only section in Chapter 7 that we're going to cover. And it's square roots and the Pythagorean theorem. And a lot of you guys have probably dealt with both, okay? But a square root is the opposite of squaring. So remember, squaring something is taking it times itself twice. So what's the square of 5? 25? So what's the opposite of squaring? Square rooting. So what's the square root of 25? Well, you just ask yourself, what times itself gets you 25? 5, okay? What's nice is that this is in the calculator section, so you guys can use your calculator. You don't even have to stop and think about it, right? But so what would be the square root of 4? What times itself gets you to 4? Nope. Squaring 4 gets you to 16. 2, right? And how I teach it, if I was teaching you by hand, this is how I teach you by hand. I'd say, okay, how does 4 break down? What two numbers multiply to be 4? 2 and 2. There's your square, right? So 2 is your answer. But guess what we can do? We don't have to do it by hand, right? We can do it on our calculator. So your square root button, guys, is actually this one right above the square. So if you have one like mine, it's blue. If you have one of the black ones, it's gold, meaning you have to hit the second key first. So hit second x squared, and that square root button will come up, and then you can just type your number right underneath there. Okay? So there's your answer, 2. What's the square root of 25? 5, right? What times itself gets you to 25? 5. But if you don't know it, guess what you can type in your calculator? Second x squared, 25, and there's 5. Okay? So some of you probably already have this all the way done, don't you? 49. What times itself gets you to 49? 7, right? The square root in your calculator? Okay.
No. I'm talking about with the...
Oh, the fraction. I'll show you that in a second. 81. What times itself gets you to 81? 9. All right, so Bree was talking about E, F, and G where it's fractions. Well, we can do it in our calculator, but it's just as easy to do by hand. You just take the square root of the top number, and that will be your answer for the top number. And then you take the square root of the bottom number, and that will be the answer for your bottom number. So what's the square root of 1? 1. And what's the square root of 64? What times itself gets you to 64? 8. So guess what the answer is? 1/8. How can you put that in your calculator though, guys? You just use your square root feature and then just do 1 divided by 64, okay? So you do second square root 1 divided by 64, and you get it as decimal, but remember my best friend, MathFrac, will change that to your fraction, okay? So looking at F and doing it by hand, we can just say, what's the square root of 16? What times itself gets you to 16? 4. And what times itself gets you to 25? 5. So what's the square root of 25? And guys, I know you cringe if I say, let's do some fraction math. But what do you get if you take 4/5 times 4/5? Do you remember how you multiply fractions? Straight across the top. Straight across the bottom. So what's 4 times 4? 16. What's 5 times 5? 25. So that's why you know you've gotten the right answer, right? The square root of a number means if you square it, you get the inside. All right, what about 25 over 49? 5 over 7. And again, you can just throw that in your calculator. Does anybody have any questions where I got any of those? Because I did those really quick. Any questions? Okay. These are called perfect squares. Anybody have an idea why it's called perfect squares?
Because they can't go into numbers.
They're like these nice little whole numbers that come out perfectly, right? They're not a decimal, all right? What we're going to get into is every number has a square root, but sometimes it's not as pretty as 2, 5, or 7. So that's when they'll say use a calculator to approximate. They want us to round to the nearest thousandths, so tens, hundreds, thousands. We have to round to 3 decimals, okay? So what times itself gets you to 2? We don't know that off the top of our head because it's not a perfect square. But if we put it in our calculator, what's the square root of 2? 1.414. And then what's behind the 4? 2. So this will just stay 1.414.
I don't get a decimal when I do that.
The square root of 2?
Yeah, I just get the square root of 2.
Do you have like a squiggly symbol? We'll have to look at yours because what it is, the square root of 2 is an exact number. So your calculator knows like a lot of times we want to use the exact number. So we will look at yours before you do your worksheet, okay? Square root of 6, what times itself gets you to 6? I don't know, right? And so what we're going to do is we're just going to do the square root of 6 in our calculator. And you're going to get the square root of 6 again, Stacy. 2.449, and what's behind our 9? A 4, so it's going to stay a 9, right? So 2.449. Any questions so far? You guys see how we're putting in our calculator? What times itself gets you to 11? I don't know.
Who knows?
3.316, but what's behind the 6? A 6, so what's that 6 going to change to? A 7. So that will be 3.317. Square root of 39, any ideas? You guys are already doing it. 6.244, but what's behind that 4? A 9. So 6.245, does that look right?
Yeah.
Those that like kind of have an idea of square roots, just kind of keep in mind if you know your perfect squares. What's the perfect square right below 39? 36, right? What's the square root of 36? 6. And then what's the next perfect square? 49, because what's the square root of 49? 7. So notice our answer is between 6 and 7. So it kind of makes sense. It's a little bit closer to 6 because 39 is a little bit closer to 36. So you could kind of estimate what the number would be, but you wouldn't be able to come up with the exact number. All right? So when do we need to use Pythagorean theorem, or excuse me, square roots? It's when you use the Pythagorean theorem. I joke about it, but it's not really a joke. This is one math theorem that you will see throughout your math career. I'm teaching Math 116. We're using the Pythagorean theorem. I've taught calculus. You use the Pythagorean theorem. You start in Math 111, and I wonder if Pythagoras knew hundreds of years ago how popular his theorem was going to be, right? So let's draw it up here. It's always for right triangles. Does everybody know what a right triangle is? It's a triangle where the two legs together come and make a right angle, okay? The two legs that make the right angle are usually labeled A and B. So this is leg, this is a leg, all right? Does anybody remember what this long diagonal one's called? Starts with an H. Hypotenuse. Have you guys heard of that before? Okay, so the hypotenuse is always the long diagonal. So what is Pythagorean theorem? It's a squared plus b squared equals c squared. Does that look familiar to anyone? A squared plus b squared equals c squared. And not until you get into calculus do I really prove where it comes from. Until then, I say just trust me that it works, okay? So a squared plus b squared equals c squared. So what we're going to always be told is 2 of the 3. So we're going to either be told 2 legs and have to find the hypotenuse, or we'll be told the leg and the hypotenuse, and we'll have to find that second leg, okay? So let's see what's going on. It says, sketch the right triangle and find the length of the side that's not given. If necessary, we're going to round to the nearest thousandth, so that's 3 decimal places again. So over here, I'm going to just kind of sketch it small. We'll do our little right angle. What are we given, guys? We're given both legs, right? So where are the legs going to go? They make that right angle, correct? So what don't we know? We don't know C, the hypotenuse. All right? So we are going to use this theorem up there. So we take one side squared, so 3 squared, plus the other side squared, 4 squared, equals our hypotenuse squared. Okay? Do we know C? No, so he's going to stay C squared for a little bit. But can't we square 3 and can't we square 4?
Yep.
We sure can, okay? What's 3 squared?
9.
9.
You can do that on your calculator.
Yep, and you can do it on your calculator now, okay? What's 4 squared? 16. And this equals C squared, right? What's 9 plus 16? Since they're on the same side, we can just do that math. What's 9 plus 16? 25. So we have 25 equals C squared. Is that our answer? No, we don't want to find C squared. We want to find C. So this is something that we haven't done before, but I kind of talked to you about it on the front page. Squaring and square rooting are inverse operations. So if we want to get C by itself, we have to do the opposite of squaring, which is square rooting. We got to take the square root of both sides. And that's something new. But don't you guys agree if they're added, we usually subtract? Or if they're multiplied, we usually divide. We're always doing that opposite operation. So the squaring and square rooting undo each other. So guess who pops out? C. And then what's the square root of 25? 5. You guys just found that hypotenuse. That third side is just 5. And if it had units, put the units down, but it doesn't. All right, so let's go ahead and draw our next triangle. This time, we're given a leg, so I'm going to write that 12, but we're given the hypotenuse, so I'm going to write that 15. And what we don't know, B. Does it matter where I put the 12? It can't be the hypotenuse, right? It can't be this side, but the 12 can go here or here. Okay, it doesn't matter. As long as your legs are on the same side, it doesn't matter, okay? So this is going to be 1 leg squared, 12 squared, plus the other leg, which we don't know, B squared, equals your hypotenuse squared, 15 squared. Does everybody see that I'm just following that equation up there? Are there any questions over those? Okay, so A squared plus B squared equals C squared. So I'm just grabbing my sides and squaring all of them. All right, so what is 12 squared? Throw that in your calculator. What was it? 144. Do we know B squared? No, let him hang out for a little bit. What's 15 squared? 225. All right, so this is a little bit different than the last one. The last one, they were just on the same side, so we could just be like, let's add them together. But this one, we want to get B by itself. So what do we need to do with 144 first? You guys got it. It's just like those equations we were doing. We want to get our variable by itself. So right now 144 is added over here. So let's move him to the other side. So what's 144? Take away 144? 0. And that's what we want. So we get B squared equals. And then what's 225? Take away 144? 81. Is 81 my answer though? No. I don't care about B squared. I want B. So how do I undo squaring? I have to square root, okay? So take the square root of B squared and B will pop out. But what's the square root of 81? You say it louder? 9. Are you guys okay? Have you seen, has anyone, who's seen this before? Okay, so a lot of you have seen it before, okay? But even if you haven't, it's just following that formula. If you're given the two legs, you can just always add them. If you're given a leg and a hypotenuse, you subtract it over before you square root, all right? Last one, we're given a hypotenuse and the leg. So my hypotenuse is going to go where? Where's the 6.4 going? Right here, is that okay? Because he's the hypotenuse, so he's going to be that long leg. Where does 3 go? It doesn't really matter, right? So it can be A or B. It doesn't matter. You can throw it on to B or A. It doesn't matter. I don't know. I always go over to the left. But if you want it to be B and you're looking for A, that's fine. All right. So what's Pythagoras say? He says take both your legs squared. So here's one leg, 3 squared, plus the other leg, B squared, equals your hypotenuse, 6.4 squared. Is that okay so far? Does everybody see why the B's not known, but the C is? Okay. So let's go square everything we know. What's 3 squared? 9. Do we know B? No. So he's going to stay B squared. And then I don't even know what 6.4 squared is. So throw that in your calculator. What's 40.96. Perfect. All right. I want to get B by itself, though. What do I need to do before I take the square root? Subtract that 9 over, right? We want to get him by himself, so we must subtract that 9 over first. So we have B squared equals whatever 40.96 is minus 9. What do you get, 31? Is that okay so far? Okay. But do we care about B squared? No. How do we get B out of B squared? We have to take the square root. But if you take the square root of the left, you got to make sure you take the square root of the right. So B equals not a perfect square, right? But up here it says round to the nearest thousandth. So let me throw that in my calculator real quick. 31.96, does that look okay? So what do we get? We get 5.653, but what's behind that 3? A 3, so it'll stay a 3. So B will be 5.653. Always, 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 your two legs will always be smaller than your hypotenuse, okay? So notice 3 and 4 were smaller than our hypotenuse 5. 12 and 9 were smaller than our hypotenuse 15. 3 and 5.653 were smaller than our hypotenuse 6.4. So kind of keep that in mind, because sometimes you might have them switched, and you might find B and he's the biggest one. It's because you've had them labeled wrong, okay? So be careful with that. All right, so what's the whole point of this? We don't just have generic triangles. We have many situations in real life where we can actually use the Pythagorean theorem to solve things. For example, you might want to know how tall that light post is up there, but you don't want to have to measure it. You can use the Pythagorean theorem and so forth, or you want to maybe measure the distance across a pool, but you don't want to have to swim across the pool, like a round pool, so you can measure the outside legs and figure out the diagonal, okay? So this has a section of land is square with each side measuring 2 miles. Let's draw a square. Let's label 2 miles. 2 miles all the way around, right? It says, find the length of the diagonal of the section of the land. Well, this is something that, again, we haven't really talked about, but the diagonal just goes from one corner to the opposite corner, okay? All right? They want us to find that length. Is that going to be A, B, or C? Say it louder, I heard it. C, right. So notice if I cover up part of that square, what do we have going on? A right triangle, right? And that diagonal is C, the hypotenuse. Okay? So according to Pythagoras, we should be able to take 2 squared plus 2 squared equals C squared. One leg, 2 squared, plus another leg squared, 2 squared, equals your hypotenuse squared. All right? What is 2 squared? 4. So we'll have 4 plus 4 equals C squared. Is that okay? Do I need to subtract anything over? No. 4 plus 4 are on the same side. So what's 4 plus 4? 8. But is 8 my answer? No. What do I still need to do? Take the square root, okay? What will pop out from C squared? A C. And then we're going to round to the nearest thousandths again. 8's not a perfect square. So it's 2.828, but there's a 4 behind the 8. So that will stay an 8. So 2.828. Does that look okay? All right? You're going to get the square 2 root 2?
Yeah.
Yep, I'll show you. Yeah. I'll come make sure we figure yours out. All right, what we have to pay attention to D and E, though, is that they're word problems. So this was measured in miles. So that's really... Okay, so maybe this farmer didn't want to have to go measure that, but he knew his plot was 2 by 2. So if he wants a fence, he knows he needs 2.828 miles to fence that diagonal in. All right, last one. A garden is in the shape of a rectangle, so let's draw a rectangle. The diagonal length of the garden is 25 feet. So they're telling this diagonal, they know it's 25. And the length of one side is 15 feet. Find the length of the other side. So we don't know A or B. It doesn't matter how you label it, okay? So we knew the diagonal, that is your hypotenuse, 25. We knew one side, either side could be 15. It doesn't matter. And then the other side is unknown. So according to Pythagoras, we'd have A squared plus 15 squared equals 25 squared. Both of your legs squared added together equals your hypotenuse, 25 squared. All right? Once you set it up, you go and square everything that you can. We don't know what A is, so he's going to stay A squared. What's 15 squared? 225. What is 25 squared? 625. And since we have one leg, what do we need to do before we take the square root, guys? Subtract over, right? We want to get him by himself, so we need to subtract the 225 over. So these will cancel, and we'll have A squared equals 400. But that's a perfect square. So Stacy, your calculator should be able to do it for you. So we want to get A by itself, so how do you undo a square? You take the square root. So the square root of A squared will be A. What's the square root of 400? not 200, but 20, okay? So our answer is going to be 20-foot garden.